So, welcome students, and this is Ravi Shankar. So, today what we are going to study is, after completing the electrical force and electrical field, we are going to study about the electrical lines of force. What do you mean by this electrical lines of force? You might have studied in your lower classes about magnetism. If you are having a magnet with a north pole and south pole, around that magnet you might have seen some dotted lines drawn in it. Usually they are calling it out as magnetic lines of force, which is also given by Michael Faraday. Similarly, in order to study about the strength of the electrical field, in order to visualize the strength of electrical field, Michael Faraday represented that with the help of some lines, and that lines are called to be electrical lines of force. So, just to see the board, it was being given thus: the electrical lines of force is given by Michael Faraday. For what purpose? To study about the electrical field, to study about the strength of the electrical field. That electrical lines of force, they are said to be a set of continuous lines, and they are used to visualize the electrical field. How we can able to get the electrical lines of force, how we can able to define, or if you are having a charge or if you are having an electrical field, how you can able to draw. There are some rules. Let us see what are the rules which are being used to draw the electrical lines of force. First of all, let us define. What do you mean by this electrical line of force? So, let us consider the definition. Electrical lines of force are, they are considered to be, so we can say electrical lines of force are imaginary, straight or a curved path, straight or curved path or curved lines along which test charge or a unit positive charge moves or tends to move inside an electric field. See, let us have a small explanation for this. See, I will be drawing a diagram and explaining it. See, you consider a charge. You are having a charge Q. You very well know that if you are having a charge Q, around that charge, you are having the influence of this charge to be felt, and the area or the space in which the influence of this is being felt is called to be electrical field. Now, inside this, you place a test charge at one particular point. When you are placing the test charge at one particular point, this test charge will be experiencing a force, because of which the test charge will try to move inside this electrical field along one path. So the path, see here I have given the path along which the test charge is moving. Along the path or the curved line, straight, that line may be a straight line or a curved line along which the test charge or the unit positive charge moves or tends to move inside the electrical field is called to be electrical line of force. An important concept and important question that you should know and you should study. What is the next question that we have to study is, and 5-mark question. See, in order to draw these electrical lines, what are the rules that we have to follow? So the next one is rules to follow or rules to draw electrical lines of force. Okay, how to draw electrical lines of force? Following some of the rules. Number 1. See, the first rule is electrical lines of force. Electrical lines of force starts or originate from the positive charge, originate or starts from the positive charge and terminates at negative charge. So it starts at or originates at positive charge and terminates at negative charge. Let us take this as the first point. See, we can also say that this positive charge starts from, or the electrical line starts from the positive charge and terminates at negative charge, or if no negative charge is available, it will be terminating at infinity. So the first point is electrical lines start from the positive charge or positive point charge and terminate at negative charge or at infinity. See, for positive charge alone, for a positive charge alone, you are considering positive charge alone, the electrical lines of force, see, the electrical lines of force are radially outwards, force or radially outwards, they are acting radially outwards, that's all. Similarly, if you are considering a negative charge, similarly for a negative charge, we can state the electrical lines of force, are radially inwards. See, all these points comprises the first point. Let us see again. You see, electrical lines of force originates from the positive charge. Let us consider originates from a point positive charge and terminates at a point positive charge or at infinity. If there is no negative charge, it will eliminate or it will terminate at infinity. Then for a positive charge, the electrical lines of force are radially outwards. Let us consider a diagram. If you are having a positive charge, they are acting radially outwards. This is what we are calling it out as radially outwards. Similarly, for a negative charge, then the electrical lines of force are acting radially inwards. This is how we can represent the radially inwards. See, this is taken to be the first point. See, when you are considering about the isolated positive charge alone, and here I have written for an isolated positive charge, the electrical lines of force, okay, the electrical lines of force starts from the charge but ends at infinity. So, electrical lines of force starts from that positive charge, but terminates at infinity. Okay. Similarly, if you are considering an isolated negative charge, for an isolated negative charge, the lines of force or the electrical lines, the lines of force lines of force starts from infinity, lines of force starts from infinity and terminate at the negative charge, and terminate at the negative charge. Clear? This is the first point. Then let us go for the point number 2. See, regarding the first point number 1, we have stated only about the two isolated charges. When you are considering a positive charge alone and negative charge alone. Positive charge alone, radially outwards, starting from the positive charge, terminating at infinity. Similarly, when you are considering an isolated negative charge, starting from infinity, terminating at the negative charge, and the lines are radially inwards. Now, let us go for the next one. Point number 2. See, point number 2, let us consider a diagram. I am having a positive charge plus Q and a negative charge minus Q. Electrical lines always starts from positive charge and terminate at what? Terminate at negative charge. If you want to calculate the direction of the electrical lines of force at any point, what we can do? So, the direction of the second point is the direction of electrical line of force at any point is any point is given by drawing a tangent at that point. Drawing a tangent at that point. Tangent at that point. See, at what point you want to get the direction. At that point you draw a tangent. Drawing a tangent at that point, which gives you the direction of electrical field as well as electrical lines. Which gives the direction of electrical lines or electrical field. So what is a tangent? See, if I want to calculate the electric direction of the electrical field or electrical lines of force here, draw a tangent. See, when you are drawing a tangent, then along that tangent, the direction of electrical field is available. If I am drawing a tangent here, see, the line of force, the tangent drawn will be like this. Along this, see, along this you will be getting the direction. So, the tangent drawn will be giving you the direction of what? The direction of the electrical lines of force or the electrical field or electrical field vector, whatever may be, no problem. Then point number 3. What is this point number 3? See, we have to calculate how many number of lines are passing through the electrical field. Always we can say the electrical lines are passing perpendicularly or normally through the given surface of the electrical field. So we can say the third point is the number of electrical lines of force, the number of electrical lines of force passing normally or perpendicularly, passing normally or perpendicularly through the given surface area, through the given surface area, through the given surface area is directly proportional to, the magnitude of the charge. Magnitude of the charge. What do you mean by this? See, number of lines is directly proportional to magnitude of the charge. See, if I am having a charge, around this charge you are having electrical field. If you are having electrical field, electrical lines of force will be available. That electrical lines of force available are acting perpendicular to that of what? Perpendicular to that of surface. Okay. If you are considering the magnitude of this charge Q If this charge Q is higher, number of lines is also higher. If charge Q is lesser, number of lines is also lesser. That is, if the magnitude of the charge is higher. That is, if the magnitude of the charge is higher. Magnitude of the charge is higher, then number of lines also higher. Number of lines also higher or more. That is, more denser. The lines are very close to each other. That is, the lines are closer. The lines are closer to each other, or the lines are, we can say, the lines are said to be closer. Similarly, if the magnitude of the charge is less, see, if the magnitude of the charge is less, what will happen? If the magnitude of the charge is less, then the number of lines, passing normally or perpendicularly is also less. If number of lines is less, that is, the lines are far apart. The lines are far apart. That is considered to be point number 3. Clear? See, the number of lines are passing normally or perpendicularly through the given surface. If they are passing normally or perpendicularly through the given surface, the number of lines available is directly proportional to the magnitude of the charge Q. If the magnitude of the charge is higher, number of lines are also more. If more number of lines are available, then it is more denser, or we can say the lines are more closer. If the magnitude of the charge is less, the value of the Q is considered to be less, then the number of lines is also less, or number of lines passing perpendicularly through the surface is also less. That is, the lines are far apart. That is point number 3. Let us go for the point number 4. What is that point number 4? We have to state the direction, the electrical field and the electrical lines. See, we know let us consider point number 4. We know that electrical field E is directly proportional to square of the radius or square of the distance. See, what is this concept? That is, electrical field decreases. Electrical field decreases with surface or with square of the distance. With square of the distance. As the square of the distance increases, then electrical field is found to get decreased and decreased. See, if you just consider a diagram, let us have a charge Q here. Around this, I am considering we are having so many electrical field around this. See, if I am drawing the electrical lines are acting radially outwards. When I am considering this point, from this point charge where the electrical lines of force are acting radially outwards, in this I am taking 2 points. One is nearer, which is at a distance of R1, and another one here, which is at a distance of R2. In both, considering both points, I am taking equal areas considering that points. So this is area A1 and this is area A2. I can say that the first area is A and the second area is B. See, the field lines, since the electrical field at A is greater than B, because A is nearer than that of B. B, that is R2 is greater than R1. As we know, electrical field is inversely proportional to square of the distance. Electrical field at A will be greater than electrical field at the point B. So, what is the conclusion? So, electrical field has a greater magnitude, or I can say, so at A, at area A or at A, electrical field has a greater magnitude. Electrical field has a greater magnitude. Whereas at B, electrical field is having lesser magnitude comparing with A. Compared with what? Compared with A. So, as the distance go on increases, then we can say the electrical field go on decreases. We can say electrical field go on decreases. If electrical field go on decreases, electrical lines will also go on decreases. So, we can say number of lines crossing A, number of lines means electrical lines. Number of lines crossing A will be greater than number of lines or number of lines of force crossing B. Clear? So, this is point number 4. See, again you recall what you have studied here. See, the fourth point is, we know that the electrical field is considered to be inversely proportional to square of the distance. That is, the electrical field go on decreases as the square of the distance increases. So, if the distance here you consider that is two distances R2 and R1, R2 greater than R1. So, if you can write like this, if R2 greater than R1, then EA, electrical field at A is greater than electrical field at B. That is, I have written here, that is at the point A or in the area A, electrical field has a greater magnitude, whereas in area B of same value or at point B, electrical field has a lesser magnitude comparing with that of A. See, if the electrical field is less, the magnetic lines of force crossing that area will also be less. That is, we have written it here as number of lines crossing A is greater than that of the number of lines crossing what? Crossing B, because A is nearer and B is far away from the charge when you are comparing with A and B. Okay, let us move on to point number 5. And very interesting and an important point may be asked, the reason may be asked for a 2-mark question. See, the point is, lines of force or lines of forces never intersect with each other. Never intersect with each other. Very important point. Why this happens? It may be asked for an 2-mark question, why the lines of force never intersect. In order to consider this, let us have a diagram. I am taking 2 lines of force. One of the lines of force is here, and I am taking this another line of force here. See, according to our concept, they never intersect. But I have drawn a line, or I have drawn 2 lines of force intersect at a point. So, in order to understand this concept, at this intersecting point, I am placing the test charge. If I am placing the test charge at this intersecting point, then this test charge should move in both the directions, which is not possible. It can move either in this direction or in this direction. It can't move in both directions at the same time. So, lines of force never intersect. Let us write the reason. See, if some charge is placed at the intersecting point. Placed at the intersecting point. Placed at some intersecting point. Then it has to move. Then it has to move in two different directions. In two different directions at the same time. At same time, which is not possible. Which is not possible. So the lines of force. So the lines of force never intersect. Clear? And very important concept for 2-mark question. It may be asked like this: why lines of force never intersect, or lines of force never intersect? Justify your answer. This is point number 5. Okay, what is this point number 6? See, we have to consider the two charges. One is the positive charge and another one is the negative charge. And we have already stated that when you are having the positive charge, it is acting radially outwards, and when you are considering the negative charge, then you can say the electrical lines of forces are acting radially inwards. This is what we have studied. Here they are again insisting that the number of lines, the number of lines either emanating from the positive charge, either emanating means coming out, emanating, either emanating from positive charge, or ending or terminating at the negative charge, or terminating at negative charge, terminating at negative charge is directly proportional to magnitude of the charge. Already we have studied this in point number 3, but in your book they have repeated it, so I have also repeated. The number of lines either emanating from the positive charge or terminating at the negative charge is directly proportional to magnitude of the charge given. That is, again, we can write like this: number of lines of force, directly proportional to then magnitude of charge. How many number of electrical lines of forces are available? That is point number 7. See, this is also an important point, may be asked in problems also. See, in your book it was being given in some other way. In simple manner we can write: each unit positive charge, each unit positive charge means 1 coulomb of charge. Each unit positive charge give rise to 1 by epsilon 0 lines of force. Clear? If you are having 1 coulomb of charge or unit positive charge, number of lines available is equal to 1 by epsilon 0 lines. But if the charge is Q, then number of lines is equal to 1 by epsilon 0 times the charge available. So this is called to be the point number 7, or this can be written as Q by epsilon 0 lines. So we can say this as point number 7. See, we have stated or studied about 7 points. in order to get the rules to draw the electrical lines of force. So when you